Okay, hello everybody. We're going to go through the Chapter 2 review packet in preparation for the test. So a couple things. I'm actually getting a little bit of a cold, so I got a little bit of a dry throat, so I'm going to do my best to get through this, but if my voice is extra annoying through all this, I do apologize. Also, don't feel like you need to watch this whole thing. I'm going to go through the whole packet. I'm going to turn this into a PDF and post it up on the website. So you can just check out those and really just use this just to see the specific problems you need. All right, so let's just get right into this. So the first one is we have to change this quadratic into standard form, which is sometimes called vertex form. So as we go into vertex form, don't forget that's going to look like y is equal to a parentheses x minus h squared plus k. This factor right here is a binomial squared, and we get that from a perfect square trinomial. So what we want to do is we want to make a perfect square trinomial. 2 is not a perfect square, nor is 5. So what we do is we factor out the 2 from the first two terms only. And we leave a blank, and we leave the 5 on the outside of the parentheses. This number we add. Because we add some number, we have to subtract the same value. What we add is this middle term divided by 2 squared. So negative 12 divided by 2 is negative 6. Squared is 36. Now because we added 36, we have to subtract the value of 2 times 36. So I'll write that there. And now, I have to factor this, but because I know it's a perfect square trinomial, because I did b divided by 2 squared, I know the factor is going to be a binomial squared. So I still have the 2 out front. I have the square root of the first term, which is x, the sine of the second term, which is minus, and the square root of the last term, which is 6, and that's squared. The 5 minus 2 times 36, 2 times 36 is 72, and 5 minus 72 is minus 67. And that is our answer. Notice this is a function, so we have to have f of x out in front. And this is it. If we were to ask what the vertex is, we'd say it's 6, negative 67. For b, same thing. We have this function. We want to factor out the coefficient of the first term, which is a 3, and we're left with x squared plus 8x. We're going to leave a blank, and the 3 is going to be on the outside of the parentheses, and because we added some value, we have to subtract some value. So here, b is 8, so 8 divided by 2 is 4. 4 squared is 16. Because we added 16, we have to subtract 3 times 16. So we get f of x is equal to 3. When I factor this, it's the square root of the first term, which is x, the sine of the second term, which is plus, and the square root of the last term, which is 4. Squared. This is minus 3 minus 48, so that's minus 51. And that's my answer. So it's a nice little process as we go through this. And I know I'm going through this fairly quickly. So if you do have any questions on anything, feel free to drop a comment or send me an email. And I will go through it. And finally this one, again, coefficient 7. So we factor out that 7 from the first two terms only. 7 parentheses x squared plus 2x plus blank minus 9 minus blank. We divide the 2 by 2 to get 1 and square it to get 1. We added 1, so we're going to subtract 7 times 1. Again, the 7 from out front. We get f of x is equal to 7. Square root of the first term is x. Sine of the second term is plus. And the square root of the last term is 1. Squared. Minus 9 minus 7 is minus 16. And there we have it. That's the answer. So for all these to put into standard form, it's a simple little process. But if you do not know the process, it can become very, very difficult. So make sure you do get some practice with some more questions like this, and check your answers to make sure you did all right. Okay, these. So we need to find x-intercepts and y-intercepts. So to find the x-intercepts, remember we need to set this equal to 0. And, ooh, made that weird. We need to set this equal to 0 and factor. So if I have 0 equals 2x to the third minus 4x squared minus 70x, we want to factor this out. So first we look for the greatest common factor, which here is a 2x, and we're left with x squared minus 2x minus 35. This is a quadratic, which is factorable. It's x squared, so that's nice. It's just going to be x and x. And here, two numbers that multiply to get negative 35 and add up to get negative 2 are minus 7 and plus 5. So we set all these equal to 0, so we get 2x equals 0, x minus 7 equals 0, and x plus 5 equals 0. X equals 0, x equals 7, x equals negative 5. Now, of course, it would be silly to leave our answers in this form because these are equations of lines. X equals 7 is a vertical line. So we write these as points. So 0, 0, 7, 0, and negative 5, 0. Now to find the y-intercept, we have to make x 0. But if you look here, we get 0 minus 0 minus 0. So it's just going to be 0, 0. Also, we can already see this right here, this point is 0, 0. That crosses both the x and y axis. So of course it's going to be a y-intercept as well. All right, so they have 7, 0. So 1, 2, 3, 4, 5, 6, 7. And negative 5, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. All right, what we need to do to find end behavior is to look. Well, this is an odd degree, and the leading coefficient is positive. That means that as we go to positive infinity for x, we're going to go to positive infinity for y. As we go to negative infinity for x, we're going to go to negative infinity for y. This is just those simple rules. So make sure you know end behavior from the chart. In terms of whether these are going to bounce or go off, remember, or go through, if we have a double root, it's going to bounce off the point. So here, if I factor this and I had negative 5 twice, so x equals negative 5, x equals negative 5, it would bounce like this. But it doesn't, so it means it's going to go straight through, and straight through. Again, don't be too concerned about finding these turning points, the relative max, relative min. For our class, we're not too concerned about that right now. What we are concerned about is the end behavior and the intercepts. And so this is perfect. This is exactly what we want. Okay? Right, so for this one, again, same deal. We want to find the x-intercepts and the y-intercepts. So this is really just an exercise in factoring. So we set y equal to 0. We make y 0 in order to find the x values, the x-intercepts, the zeros. Greatest common factor here is x, so we get x squared minus 4. So we get 0 equals x times x plus 2. X minus 2 because this is a difference of 2 squares. So we set these three factors equal to 0, x equals 0, x plus 2 equals 0, and x minus 2 equals 0. We get x equals 0, x equals negative 2, x equals positive 2. Again, we can't leave our answers like this. We write them as coordinates. So we get 0, 0, negative 2, 0, and 2, 0. And again, if we have this point 0, 0, that crosses both the x and the y-axis, or I can make x 0. So I get 0 minus 0 to see that the y-intercept is also in 0, 0. And I get this. Just as the previous one we did, there are no double roots. The degree is odd, and the leading coefficient's positive. So we're going to go to positive infinity to the right, negative infinity to the left. And these are just going to go bounce up, bounce down. And that's it. And again, as I said in class, like, don't be too concerned about whether it looks like that or, like that. Just make sure that we're focused on the end behavior and the intercepts, and that's all we need to focus on. All right, so that's it for the graphing, and now we're on to division. So this is polynomial long division. What we need to watch out for are placeholders. Here we can see we have the degree is 4, and all the powers are in descending order. So 4, 3, 2, it's a 1, and this is really a 0. If we didn't have a value, we would need to put in a 0 x to whatever power. So for example, if we didn't have 14x squared, we would need to write in plus 0 x squared. All right, so I'm going to set this up. Wow, that's not a good line there. All right, take 3. Oh, Jesus. Yeah, this pad that I write on is not the best. Okay, there we go. That's at least I can do the math, right? All right, so let's do the math. So when we divide the first term by the first term. We'll change up the colors here. So 64x to the 4th divided by 8x. That is 8x to the 3rd. Because it's x to the 3rd, I put it in the x to the 3rd column. And now I take this and I multiply by out front. So I get 64x to the 4th. 8x to the 3rd times negative 2 is minus 16x to the 3rd. Now what I do is I subtract these values. The first term should cancel out, so it should be 0. I get 56x to the 3rd minus a negative, so that's plus 16x to the 3rd. So that's going to be 72x to the 3rd. Then I bring down my 14, so plus 14x squared. 72x to the 3rd divided by 8x. That's going to be 9x squared. 9x squared times 8x is 72x to the 3rd. 9x squared times negative 2 is minus 18x squared. I'm going to subtract these values again. Again, the first terms cancel out. So we get 14x squared minus a negative 18x squared is positive 32x squared. Bring down this 40x. And I have 32x squared divided by 8x. That's going to be a plus 4x. 4x times 8x is 32x squared. 4x times negative 2 is negative 8x. We subtract. We get 0 for the first term. And 40 minus a negative 8 is going to be 48x. There are no more terms left to bring down. So this means that this is going to be my remainder. So I have plus 48x. Actually, no, you know what? I'm wrong, because I even said we needed a placeholder. We need a placeholder here. We need x to the 0 power. So we actually need a 0 in there. So we bring down this 0. And now we say, what's 48x divided by 8x? That's 6. So we get plus 6. And that's going to be 48x. 6 times negative 2 is minus 12. We subtract these, and we get positive 12. This positive 12 is our remainder. So we have plus 12 over the divisor, which is 8x minus 2. And this is our answer. Sorry, I almost forgot. Yeah, so we have x to the fourth, x to the third, x squared, x to the first. We need an x to the 0 power. Basically, we need a constant as well. There is not one here, so we have the plus 0 as our placeholder. Bring that down, we can divide this last 48. Once we have nothing left to bring down, so no more constants, we're left with a constant value. That's going to be our remainder. We write our remainder over the divisor. All right, let's do another one. So we get 4x to the third plus x squared. Again, we don't have a 0, or we don't have an x, so we need a placeholder plus 0x minus 6, and we have 4x plus 1. So what we do is we divide. So the first term is just 4x to the third divided by 4x. That's going to be an x squared. I put that over the x squared, and I multiply. So x squared times 4x is 4x to the third. X squared times 1 is plus x squared. And we subtract. The first two terms should always cancel out. Here, the next two terms also cancel out, but I'm still going to write as 0x squared. And I'm going to bring down my plus 0x. It seems unnecessary, but at least for me, it's a nice way to keep track of this. And I recommend you do it as well. So 0x squared divided by 4x, that's just 0 and 0x. 0 times everything out front is going to be 0x squared plus 0x. We subtract, and we get 0x. We bring down the 6, so minus 6. And we have 0x divided by 4x is, again, just going to be a 0. So we multiply everything. So 0x plus 0. We subtract, and we're left with a minus 6. That minus 6 is our remainder because there's nothing left to bring down. So we get minus 6 over 4x plus 1. We don't really like to write zeros, like 0x and 0 in our answer. So I'm going to write the answer as x squared minus 6 over 4x plus 1. And that is our final answer. Nice simple one there, I thought. But yeah. All right, and I think this is the last one. So we get 6x to the fourth minus 9x to the third plus 21x squared plus 108x plus 61. So we have all of our powers there, including a constant. So we don't need any placeholders. We get 6x plus 9. Okay, so we divide the first terms together. So 6x to the fourth divided by 6x is x to the third, which I put right there. X to the third times 6x is going to be 6x to the fourth plus 9x to the third. This is where I saw people get confused on the quiz. Make sure you subtract. So here the first two terms cancel out. This is negative 9x to the third minus 9x to the third. If you need your calculator, you can use it, but you get negative 18x to the third. They do not cancel out, so be careful with that. Plus 21x squared, so negative 18x to the third divided by 6x is minus 3x squared. Minus 3x squared minus 6x is minus 18x to the third. Minus 3x squared times 9 is minus 27x squared. And again, we subtract. First two terms cancel out, and we get 21x squared plus 27x squared as 48x squared. And we bring down the 108x. Divide again, so we get 48x squared divided by 6x. That is 8x. Oops, and we multiply. That's an ugly x. That's better. We multiply. So 8x times 6x is 48x squared. 8x times 9 is 72x. We subtract both terms. First terms cancel out. 108x minus 72x. That gives us 36x. We bring down the 61. 36x divided by 6x is a positive 6, and we multiply. 6x times 6x is 36x. 6x times 9 is 54, and we subtract. First terms cancel out. 61 minus 54 is 7. Nothing left to bring down. That is our remainder. So we get plus 7 over 6x plus 9. Okay. I said in class it's like lather, rinse, repeat. We divide the first terms, put the quotient up top, multiply, subtract, and repeat. Divide the first terms, put the quotient up top, multiply, subtract, repeat. Same 3 steps over and over again. And for the most part, you guys did well in the quiz. Just make sure that on the test you do get some good practice and minimize your simple mistakes. Like don't say that negative 9x to the third minus 9x to the third is 0. Double check that stuff. Okay, these. All right, here we go. All right. What we need to do, we need to find the possible zeros. This is a rational zero theorem. So we take the p, so the possible zeros are all the p over q, and these are, of course, plus or minus. We take all the factors of the constant and divide by all the factors of the leading coefficient. Here the factors of the constant are 1. Leading coefficient factors are 1, 2, and 4. So we're going to have plus or minus 1 over 1, which is 1, plus or minus 1 over 2, which is 1/2, and plus or minus 1 over 4. This is nice because 1's, has only one factor. Some of them you could have multiple combinations, which we'll see. And then we just start dividing. So we want to synthetically divide. It's basically a guess and check strategy. So to synthetically divide, I put the coefficients of all the terms and the constant. And on the outside, I put a possible 0. So I can start with the negative 1, bring down the 4. Negative 1 times 4 is negative 4. Add. Negative 1 plus negative 4 is negative 5. Multiply to get 5. Add. Negative 1 times 1 is negative 1 and 0. And look at that, on my first attempt, I got 0, so there's no remainder. So that means that a real 0, negative 1 is a real 0. And then I get this. So I get 4x squared minus 5x plus 1. If we want, we could keep dividing in possible zeros into this, or we could factor this. So we could try and factor this. And I'm just going to guess with this. Obviously, a bunch of different strategies you can use. AC, box method, slide and divide if you want it to. Here, this is kind of nice because 1 has only one factor, so I know these last two numbers are going to be 1. They're adding up to get a negative, multiplying to get a positive, so they both got to be negative. And I can check this, and it does work out. So I get 4x squared minus 4x minus 1x is minus 5x. Negative 1 times negative 1 is positive 1. So I set these two factors equal to 0. Yeah. I went too quickly there. X minus 1 equals 0. I solve these, so I get x equals 1/4 and x equals 1. And if you notice, these are 2 of the zeros that were possible. So I can write these as a list, or if you wanted to, you could write these as points. Here I'm not picky about what you should do, but I mean these are the same thing. And that's it. That's all we're doing. So we take the p's, the q's, divide and see what we get. All right, so same thing here. We're going to take the possible values, the factors of here, which are, again is just 1, and the factors here, which are 1 and 3. So we get plus or minus 1 over 1, which is 1, and plus or minus 1 over 3. So that's actually not bad. If you think about it, never mind. So we'll synthetically divide here. So we get 3, negative 1, negative 3, 1. And let's start again with negative 1. So we get 3. Multiply here, negative 1 times 3 is negative 3. Get a negative 4. Multiply these together to get a 4. Add these together to get a 1. Oof, 2 negative 1s in a row. Fantastic. So that means that negative 1 is a 0. That's great. But there are probably some more zeros here as well. So I'm going to factor this quadratic. And this should be a nice one because 3 is prime. So that means it must be a 3x and an x. And 1 only has the one factor of 1 and 1. They add to get a negative, multiply to get a positive. So those have got to be the two factors. Set them equal to 0. So I get 3x minus 1 equals 0. And x minus 1 equals 0. So I get x equals 1/3 and x equals 1. So negative 1, 1, and positive 1/3. That's it. One more. Oh, that's a shame. I should have chose some better examples here, but the p-value again just has the one factor of 1, and this has factors of 1 and 2. So the possible zeros we get plus or minus 1 over 1 and plus or minus 1 over 2. The real zeros we synthetically divide, so we get 2, negative 1, negative 2, and 1. Oh, let's start with negative 1 again, shall we? So we bring down the 2, multiply. So negative 2, that's going to be negative 3. Multiply, that's going to be 1, negative 1, 0. Oh boy, I'm on a roll here. So again, this means that negative 1 is a 0, so x equals negative 1. And we get 2x squared minus 3x plus 1, set that equal to 0. We want to factor this. Again, 2 is a prime number, so we get 2x and x. We get 1 and 1. And that's how we factor it. Again, like I'm going through the factoring quickly because that's something we looked at before. There are videos, even on this channel, that you can check out. All those methods of factoring. I don't want to take the time right now to review those factoring methods because you can check that out in addition to this. But I set these factors equal to 0, and I get 1 and 1/2. And those are the possible zeros, and these are the actual real zeros. So a nice little process of looking at your P's and Q's, minding your P's and Q's, if you will, and then also synthetically dividing, which is great. Okay. These are actually not bad. I know there's some confusion on the quiz about methods and all that stuff. What we want to do here is we want to add, if it has this sign between, it means we're adding, subtracting. No sign means we're multiplying. So here's what we're doing. We're combining like terms. So we get 2 plus 4 minus 3i plus 6i. This gives us 6 plus 3i. That's it. I'll move on to 12 first. So we get 7 minus 10 minus 9i minus a negative 2i. Some of you guys might be looking at these steps and being like, do I really need to write out all these steps? Well, if you find that you're getting these wrong, then yes, you need to write out all these steps. When you write out all the steps, it makes it more difficult to miss things such as, this is negative 9i plus 2i, which is negative 7i. Also, if I'm grading, I will give partial credit, so don't miss out. When you multiply, you want to FOIL. And foiling, you're basically going to treat the I as you would a variable, except I squared is -1. So here, 3 times 7 is 21, minus 18i, plus 28i, minus 24i squared. I'm going to simplify this so we get 21 plus 10i. Here, I squared, don't forget I squared equals -1. So I replace that with the -1 to get 24. And what I get is 45 plus 10i. Down here, and that's my answer. I can't really box that. Down here, we get, again, FOIL. So 56 minus 8i plus 21i minus 3i squared. Cleaning this up, I get 56 plus 13i. I squared is -1. So -3 times -1 is +3. So I get 59 plus 13i. And that is the answer. So these are really straightforward. They're meant to be quick, easy points. But, again, make sure you do get some good practice with them. All right, we're finding the zeros, and these are all zeros in the complex system. So again, to find zeros, we make y 0, and we solve. This is a quadratic, so we factor. You could set this equal to 81 and, get some square roots here. But you're looking at a fourth root, and that may be too complicated. So I'm going to see that this is a difference of 2 squares and factor. And then if I look again, oh no. X squared minus 9 is also a difference of 2 squares. So I get x plus 3, x minus 3. Set these factors equal to 0. X squared plus 9 equals 0. X plus 3 equals 0. And x minus 3 equals 0. So solving, I get x equals 3, x equals -3, x squared equals -9, x equals the square root of -9, square root of -9 is plus or minus 3i. So if we write these as points, we get -3, 0, 3, 0, 3i 0, and -3i 0. Honestly, that's a little bit weird with those imaginaries as points, but it's not a big deal. All right, and that's it. That's it. So we're going to have zeros just as we did before, just as we did with those problems where we had to graph. But now we just have some imaginary ones as well, and that's fine. Here, same deal. Set equal to 0 and factor. When you factor, you want to factor out the greatest common factor first. In this case, it's an x. So we get x to the 4th minus 16. Oops. X to the 4th minus 16 is a difference of 2 squares. So I get x squared plus 4, x squared minus 4. X squared plus 4, we're going to leave like that. Can't factor it, but x squared minus 4 is again a difference of 2 squares. So we get x plus 2, oops, x minus 2. And we set these equal to 0, so we get x equals 0, x squared plus, oh boy, oops, I'm struggling here, oh boy. Oh no. X squared plus 4 equals 0. There we go. All right, we're back in this. All right, again, set all these factors equal to 0. Again, some of you may be asking, like, do I need to do this? Well, again, if you're getting these answers wrong, then yes, you need to do this. X equals 0. 0 is just x equals 0. Here we get x squared equals -4. Take the square root, so we get x equals the square root of -4. So x equals plus or minus 2i. We can write this as a list. That's all right. So x equals 0, plus or minus 2, and plus or minus 2i. And I've been saying write these as points, but here there are 5 of them. It's all right. Okay. And the last one, I'm going to guess Oh, this is a a good one. This is a good one. So f of x equals 2x squared plus 32x. So again, we set this equal to 0, so 2x squared plus 32x. Factor out the greatest common factor, which is an x, so we get 0 equals 2x, and this is going to be x plus 16. I now realize that it should have been 2x squared plus 32. This is silly. There are just two real solutions. 2x equals 0. X plus 16 equals 0. So we get x equals negative 16. X equals 0. So our zeros are going to be 0, 0. Negative 16, 0. Yeah, this one, I made a mistake with the actual problem. So we only get two real solutions. But that's fine. So hopefully this one didn't cause you problems, because if you factored this correctly, you would get two real solutions, and that's it. So that's fine. Don't expect that on your test, because on your test I will give you one that has some imaginary zeros as well. At the top of this was kind of cut off, but we got f of x is equal to 9x over x minus 9. What we want to do is we want to find all the different pieces here. Yeah, so wholes, remember, are when we have common factors in the numerator and denominator. Both cases here, numerator and denominator are, I can rewrite this. They're already factored. You can't factor these anymore. So there is no common factor, so there are no wholes. We can just write none. X intercepts, you set the remaining factor in the numerator equal to 0. So we get x equals 0. But the x-intercept is an actual point, so we write it as 0, 0. To find the vertical asymptotes, we set the remaining factor in the denominator equal to 0. And we get x equals 9. So, so we get x equals 9. It's a vertical line, so we just leave it as x equals 9. The y-intercept, we make x 0, so we get 9 times 0 over 0 minus 9. Which is 0 over negative 9. This 0 divided by negative 9 is 0. So it's 0, comma 0. Don't write negative 1/9 or something silly like that. Also, as soon as we see that the x-intercept is 0, 0, again, the y-intercept is the same thing. And the horizontal asymptote is going to be the rule. So we have the degree in the numerator is 1, degree in the denominator is 1. Because they're the same, we divide the leading coefficients. So we get y is equal to 9 over 1, or y is equal to 9. All right, pretty straightforward stuff there. With this one, there is some factoring involved. So what I'm going to do, I'm going to factor this right off the bat. X plus 5 times x minus 5. Let's highlight this. So here we get these two common factors. So we can reduce them. X plus 5 over x plus 5 reduces to 1. And we're left with x minus 5 in the denominator. I'm going to go a little bit out of order here. I'm going to start with the horizontal asymptote, because that's just finding the degree. The degree in the numerator is 1, in the denominator it's 2. Because the degree in the denominator is larger, that means that the horizontal asymptote is y equals 0. Well, y equals 0 is the x-axis. So if it's the x-axis that this graph can't exist on, there aren't going to be any x-intercepts. That's it. Also, look at the remaining factor in the numerator. What value of x is going to make 1, 0? It can't happen. No matter what x is, the number 1 will never be equal to the number 0. So that's why we get no x-intercepts. Going back to look at the wholes, we have that common factor in the numerator denominator, which is x plus 5. Set that equal to 0 to get x equals negative 5. That's not a point. The whole is not a point. It's just x equals negative 5. Later on, you're going to find limits, and you'll see we can imagine where the limit is, where it's going to, but we can't say this is a point, so we just leave it as x equals negative 5. The y-intercept, we want to make x 0. We can do that in either this original function, or we can make it here. So we get 1 over 0 minus 5, which is just negative 1/5. So we get 0, comma, negative 1/5. And the vertical asymptotes is we set the remaining factors in the denominator equal to 0. So that's x minus 5 equals 0. So x equals 5. And those are my different pieces. Okay. Pretty straightforward. You can jump around. Don't feel like you have to go in order. Follow a process that's logical for you. I like starting off the horizontal asymptote and then going to the holes, X intercepts, vertical asymptote, Y intercept. Don't feel like you need to go right down the list. But do make sure you factor and you write your steps. Don't write your numerator factor all the way over here and your denominator factor all the way over here. Keep them together. All right, these problems. Back to complex numbers. We want to write these in standard form. Standard form is a plus bi, where a and b are real values, and I is obviously the imaginary. So the problem here is that we have denominators, so we need to get rid of them. So what we do is we multiply both numerator and denominator by the conjugate of the denominator. For the denominator, we're going to have a difference of two squares, so we get 9 minus I squared. The numerator we just FOIL, so we get 15 plus 5i plus 6i plus 2i squared. Again, I squared is negative 1, so we get 15 plus 11i minus 2 over 9 plus 1. This is the same thing as 13 plus 11i over 10. So we get 13 over 10, that's our A value, plus 11 over 10, I. That's our B value. And that's it. That's it. Do a different color here. 23. Again, we get 2 plus I over 4 minus 2I. We need to multiply numerator and denominator by the conjugate. Denominator is just going to be a difference of two squares, so we get 16 minus 4i squared. Numerator we FOIL, so we get 8 plus 4i. Ooh, plus 4i again. Delightful. And plus 2i squared. Going down, working this downwards, we get 8 plus 13i. I squared is negative 1, so we get minus 2. Over 16 plus 4, because I squared is negative 1. So we get 6 plus 13i over 20. Split these apart, we get 6 over 20, which is 3 over 10, plus 13 over 20i. Always reduce the fraction, always reduce it. And for the last one, let's choose green. Nice little Kelly green. Is that Kelly green? I think it's Kelly green. Here we're going to multiply the numerator denominator by the conjugate of the denominator, so that in the denominator we get a difference of two squares, 9 minus 16i squared. Numerator we FOIL, so we get 15 minus 20i plus 18i minus 24i squared. So we get 15 minus 12i plus 24, because I squared is negative 1. I squared is negative 1, so instead of 9 minus 16i squared, we get 9 plus 16. So here we're going to have 39 minus 12i over 25. Oof, running out of room. So we get 39 over 25. Oops. Not plus, minus 25 equals 39 over 25 minus 12 over 25i. Can't reduce the fractions there, so that's our answer. Put these in little boxes. That way the teacher knows these are my answers, and I'm good. Again, another process that's you know, it shouldn't be too complicated. It's multiplying numerator denominator by the conjugate of the denominator and reducing fractions. We treat I as a variable, but remember we substitute I squared for -1. We substitute -1 in for I squared, and I just stays I. And we get it so it's A plus BI, A plus BI, A plus BI. Here B is just negative. Okay, and finally the last page. Here are just photos of these problems. They're the graphs. We're not really going to be focusing on graphs. We are just going to be matching. What I recommend for these problems is sort of using a process of elimination. Start with asymptotes. So if we look here, there are a whole bunch of asymptotes. And so with this one, with the first one, let's start with just finding the horizontal asymptotes. So the horizontal asymptote for the first one is going to be y equals 0 because degree is greater in the denominator. Second one, y equals 2, because these are equal. We divide the leading coefficient. Number 3, I think that's a 3 up there. Yeah, that's a 3. So because the degree is bigger, there is no horizontal asymptote. Here, they're equal, so we get y is equal to -1/2. Here, again, the degree is greater in the numerator, so there is no horizontal asymptote. Number 6, we get that y is equal to 1/2. Number 7, they're equal, so y is equal to 3. Number 8, degree is greater in the denominator, so y equals 0. And here they're equal, so y equals 3 again. We can see some of them are repeated. Y equals 3, y equals 3, so that's y equals 0, y equals 0. So there's we'll have to find out other pieces. But others are not, like y equals 2. That's the only one where the horizontal asymptote is y equals 2. So I look at these graphs and I look for where y equals 2 is a horizontal asymptote. It's not A, it's not B, it's not C, it's not D, not E, not F, not G. Oh look, H. H has a horizontal asymptote at y equals 2. So what I can do is, sort of cut that out of there and say that's probably my answer for number 2. Process of elimination. Here, y equals -1/2. Well, where's my horizontal asymptote at y equals -1/2? And we can see right there, if this block is -2, halfway is -1, so that looks like it's -1/2. So -1/2 is going to be I. Here, number 6, it has a horizontal asymptote at y equals 1/2. And it looks like that's K. So already, just by finding horizontal asymptotes, I have 3. Right off the bat, I have 3. Now the other 4 have similar asymptotes. So what I'm going to need to do is I'm going to need to find a little bit more. If I look at here, y equals 0, there are no common factors, so I don't need to worry about holes, but vertical asymptotes, if I set this denominator equal to 0, I'm going to have x times x minus 3 equals 0. That gives me vertical asymptotes at x equals 0 and x equals 3. So 2 vertical asymptotes. All right, well, let's see. This one looks like it has 2 vertical asymptotes, but that's, what, -1 and 3? So it's close, but it's not 0 and 3. Here, oh look, 0 and 3. So this B must be the answer for 1. I'll make that a little bit smaller so it fits. It's just a nice little process of elimination here. So if y equals 0 has a horizontal asymptote there, with these 2 vertical asymptotes, number 8 also has a horizontal asymptote at y equals 0. So which of these other graphs has a horizontal asymptote at y equals 0? Well, it looks like it's D. It does look like it's D. But F also looks like it has a horizontal asymptote at y equals 0, doesn't it? 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh no, there are I didn't realize this. There are more pictures than there are graphs. Okay, so it's either going to be F or D, depending on where the where the vertical asymptote is. So either at x equals 2 or x equals -1. Okay, so now we have to find the vertical asymptote. So y equals 0. Where am I at? Yes, so 8 is going to be either D or F because they both have horizontal asymptotes at y equals 0, but they have different vertical asymptotes. So let's actually find out what the vertical asymptotes here are going to be. And here we can factor the numerator and denominator. So when we factor that, we're going to get -3 over x minus 4 over, this is going to be x minus 4 times x plus 1. So this will give us a hole at x equals 4 and a vertical asymptote at x equals -1. Whoa, is that a hole? That's a hole. And a vertical asymptote at x equals -1. So that means that F is the answer for 8. Try to make that fit so everybody's happy. Great. Okay, no horizontal asymptote. So what we need to look at for those, we should probably find out, again, the vertical asymptotes. So with 3, if we look in the numerator, we're going to factor out a common factor of x, and we're left with x squared minus 9, which is a difference of 2 squares, so we get x plus 3, x minus 3. In the denominator, we factor out a 3, and we get x squared minus 2x minus 9, or sorry, minus 3. And we factor that to be x minus 3, x plus 1. So here we're going to have a hole at x equals 3. We're going to have a vertical asymptote at x equals -1. And we're going to also have X intercepts at 0, 0 and -3, 0. So let's check out. No horizontal asymptote with a vertical asymptote at x equals -1. Whoops. Sorry, I'm losing my place there. This one has a vertical asymptote at x equals -1, but also, a horizontal asymptote. So that's not going to work. Here, vertical at x equals -2. No vertical there. No vertical. Here we go. Vertical asymptote, x equals -1. This is the only graph that has no horizontal asymptote, and the vertical asymptote at x equals -1. So that means that this must be the answer. So I can put that right there. So number 5 also has no horizontal asymptote. We can see A does, C doesn't, D does, E doesn't, and J does. So it's either going to be C or E based off of where the vertical asymptotes are. So with this one, again, number 5, we can factor this much in the same way. So in the numerator, we get x times x plus 4, x minus 4. And in the denominator, we factor out a -4. So we're going to get x squared plus x plus... Oh, we factor out a negative, sorry. So that's minus x minus 6. So I'll write this down here. So this is going to be -4. And we're going to get x minus 3, x plus 2. So there are no common factors, so no common holes. So we're going to have two vertical asymptotes here at x equals 3 and x equals -2. My brain just does not want to work today. It's the weekend, you know. It's tough. X equals -2. That's an x. That's an x. So which one has two vertical asymptotes? Right there. That's C. -2, and at 3 we have those two vertical asymptotes. So that means that the answer for number 5 is going to be C. And we have two more that have horizontal asymptotes at y equals 3. So that's either A or J, again depending on where the vertical asymptote is going to be. Here, if we factor out the numerator, we can get 3 times x plus 2. There is no hole. We can see that the vertical asymptote is going to be x equals -3. So if we look at these, we can see that x equals -3 is J. So that's going to be the answer for number 7. And by the process of elimination, we can settle that A, which also has a horizontal asymptote at y equals 3, is going to be the answer for number 9. So with this, problems like these, we have to find all the different pieces, holes, x-intercepts, y-intercepts, fill out the box. But with matching graphs, really the strategy is not to find all the pieces, but to find out the horizontal asymptotes. They're quick, they're easy to find. It's those 3 rules. Once you find them, you can go back and use a process of elimination and also look at your x-intercepts to help you find out the difference between graphs that have the same horizontal asymptotes. This is material for the test. This has been going through the entire review packet. If you watch the entire thing, good for you. That's a lot of watching. It's a lot of listening to me talk, which I know is not entertaining, especially with me right now having a little bit of a head cold and being extra nasally. Yeah, look, if you have any questions on any of this, again, I know I went through this a little bit quickly, but if you have any questions, drop me an email, leave a comment on this video, and overall, do what you need to do well on this test coming up. Right, all right, guys, happy studying.